Welcome to Sundar's lecture. This is lecture number 42, and in this lecture we are going to solve another problem. And what are all the topics we have seen in the previous class? We have taken a numerical problem, that is a pure capacitive circuit. We are giving AC supply to pure capacitive circuit, and we have found that what is XC and what is the value of Z, and we have got what is the IRMS value and what is the equations for voltage and current. These are all the topics we have seen in the previous class. And now in this class we are going to take RL circuit, RL series circuit, right? What is the question given? See, a 100 ohm resistor and a 20 millihenry inductor are connected in series across a 230 volt 50 hertz supply. Find circuit impedance, admittance, current, voltage across R and L, apparent power, active power, reactive power, and power factor. So this is the question given. So first what you do, you try to draw the circuit diagram so that it will be easy to understand. So an inductor and a resistor is connected in series, right? So first I will draw the diagram. So this is the resistor and there is an inductor also connected in series, right? So this is the connection, and now we will connect this one. So here an AC supply is given, right? So we will draw like this. So it will be like this. So an AC supply. Now you see there is a AC supply is connected. So this is the AC supply, and what is the value of AC supply they have given you? That is nothing but it is 230 volt 50 hertz supply. So it is 230 volt, 50 hertz supply is given to the RL circuit. What is the value of R? R is nothing but it is 100 ohms. So R which is equal to 100 ohms, and what is the inductor value given? 20 milliamperes, right? So inductor, that is L, which is equal to 20 not milliamperes, it is millihenry anyhow. So this is the given question, right? And what are all the parameters they have given you? You just listed down here, given data. We will write that one first so that we can easily substitute that in the equations. Given data. So we have many data, right? One is R is equal to 100 ohms given, and L is equal to 20 into 10 to the power of minus 3 Henry is given. Frequency is equal to 50 hertz given, and VRMS value. See, try to understand whatever the value they have given you, that is nothing but it is the VRMS value. I will write directly V is equal to 230 volt. Here they have not given you anything else because see, V is the reference value here. So we can write like this, R we can also write V, which is equal to 230 plus J0 volt. Since there is no any phase shift, we can write like this, right? That is also correct answer. Okay, right. Now what is the first question they have asked you to find? So impedance value. What is the circuit impedance? Circuit total impedance. They are asking you to find circuit total impedance. So you know the formula, right? What is the formula for impedance? Impedance, I have told you already. Impedance Z, which is equal to R plus J X L. See, here I am writing it as XL since this is the resistor and inductor connected, series connected circuit. That is why I am writing here R plus JXC. If I have a capacitor, then I have to write, we have not solved equations for that. Anyhow, we will write R minus JXC, right? This is how we need to write the exam. We need to write the equations, right? Now, they have given you both, they have given you what is R. We know that it is 100 ohms, but they have not given you XL. Directly they have not given you XL. So how to find XL? So to the formula to find XL will be is equal to 2 into pi F into L. Right? This is the formula to get the XL value. That also we have already seen. So this should be is equal to 2 pi into 50 into, what is the L value given? L is 20 millihenry. So it is nothing but 20 into 10 to the power of minus 3. right? And what is the XL value you will get right now? So if you solve this expression XL, then you will get XL, which is equal to, you will get 6.2831 ohms. So this is the XL value. This is the XL value. Now you can write the Z value here. So what is the Z value? Now Z can be written as R value, that is 100 plus J 6.2831 ohms. This is how you can get the values. And also you see, this is the rectangular form. Form of writing the expression will be 100 plus J 6.2831 ohms. And you can also write this Z in the polar form, so that you will get modulus of Z. So polar form will be is equal to what? Polar form will be is equal to modulus of Z at an angle of degree pi. Right? So how will you get this Z value? Z will be is equal to square root of 100 square plus 6.2831 square. One square, right? So modulus of Z, that can be found by using the formula 100 square plus 6.2831 the whole square. Right? What is the modulus of Z you will get now? So modulus of Z, that should be is equal to 100.1972. So that is the modulus value. That is the modulus value. And how will you find pi? Pi value, what is the formula to find pi? Tan inverse of XL by R, right? And what is this one now? So tan inverse of, what is the XL value here? This is the XL value, right? This is the XL value. So 6.2831 divided by 100, right? This is the pi value. So if you find what is pi, then pi will be is equal to 3.595 degree. That's all. So now how will you write this Z? So Z will be is equal to, what is the modulus of Z and pi? One pi value. So you have to write the modulus of Z, that is 100.1972 at an angle of 3.595 degree ohms. Simple, right? So we have just converted this term, rectangular form, into polar form. That's all, right? So now you will get the, so this is the Z value now. That is the first question also. What is the admittance value? So how will you find admittance? So admittance, what is admittance? This is the new term to us, admittance. That means admittance, I will write it down. Admittance, that is denoted by Y now. That is denoted by Y. So admittance. So admittance value, which is nothing but it is the inverse of impedance value. That's all. So directly, you see, if they are asking you to get the value of impedance, this is the impedance value. See, you have to find what is the modulus of impedance value. Always you go for modulus values. You don't go for this one. Anyhow, this is the correct answer, but always you write it down as the 100.1972 ohms. That is also a correct answer. Anyhow, so we will do this one. So 1 by Z value. What is the 1 by Z? So 1 divided by 100.1972. Right? So I will bring this to here. So 1972. And if you simplify this, maybe this is Y value. Modulus of Y, I will not write like this. Modulus of Y, I will not write anyhow. So Y value, if you simplify this one, so if you simplify this one, you will get 9.9803 into 10 to the power of minus 3. Anyhow, if you get an angle also, you also write this one, right? 3.595 degree. And if you write like this, then you will get, this is at an angle of minus 3.595 degree. That's all. Simple. See, if you get it to the numerator, then the value becomes negative, right? Degree values become negative. So this is also in ohms, right? So this is how you need to find what is the value of Y. That means admittance. Next one, you need to find what is the value of current, right? So current. So I will take a new page. See, I need to find what is the current value, right? So to find current, that means I value. I can be written as what? V by Z. And what is the V value? V, which is nothing but it is 230 volt at an angle of 0 degree. I have told you already, right? See, I have written like this. Maybe it can be written like this also. So if you take a modulus, convert this value to the polar form, then you will get 230 at an angle of 0 degree, right? So you can write like this, right? So divided by, and what is the Z value? Z value we have found it as 100.192 at an angle of 3.95 degree. So 100.192, 100.1972 at an angle of 3.595 degree. Am I right? Right? Yes, 3.595 degree. I'm right. So if you simplify this one, see here it is a 0 degree, right? So if you it can be uh, taken to the numerator, and if you divide these two, what is the I value I am getting? So I will be is equal to I am getting 2 point, that is 2.2954 at an angle of minus 3.595 degree amperes. So this is the value. This is the final value. So or you use calculators to find these values. It is very simple, right? Then so we have found I value. So what is the next one? So current has been found. What is the voltage across R and L? So what is VR and what is VL? That is the question, right? And what is the formula? We know already, we have seen this. Already we have seen what is VR which is equal to I into R. This is the formula. And what is I? So you see, always you substitute these type of values, right? What is this one? This is the I value. So if you substitute this value, that is 2.2954 at an angle of minus 3.595 degree into what is R value? That is nothing but it is 100. Right? 100. So if you further simplify this one, what you will get? So finally I will get VR which is equal to 1229.54 at an angle of minus 3.595 degree volt, and this is the VR value. And what is the formula to find VL? VL will be is equal to I into XL, right? This is the value. So what is this one? If you substitute this one, what is I? 2.2954 at an angle of minus 3.595 degree into what is XL value, you know, right? What is the XL value? Try to understand this one. XL, while writing the XL value, see we have found this is XL, right? This is the value of XL, and wherever you go, your XL value you see here. If you want to write this XL value alone, then you come here, you have to write it as 6.2, maybe what is the value? 2831 at an angle of 90 degree. Why I am writing this as 90 degree? Try to understand, because you see what is the Z value? In Z, R value will be 100, but what is the value of XL? XL value is with J, and what is J? Operator plus J operator will be 90 degree, right? You have to write it as 6.2831 at an angle of 90 degree. At an angle of 90 degree. So I have written like this. So if I simplify this, I will get VL, which is equal to, I am getting 14.422 or 222 at an angle of 86.405 degree volts. So this is the final value I am getting for VL. And what is the next question? Next question will be apparent power, right? What is the value of apparent power? So apparent power, I will write what is the formula for apparent power we have seen. S is the denotation. S will be is equal to V into I. That is the formula for apparent power. And what is the V we have got? We have given this. This is the given value of V, right? This is the given value of V. So it will be 230 volt into, and what is the I value we have found? See, whenever you are finding out the apparent powers or active or reactive powers, you just go for modulus values. Modulus values that will give you the perfect answers, right? So you see, phi I, what is the value of I here? That will be 2.2954. That is the apparent power value. And if you simplify this, I will get S will be is equal to, I'm getting 527.942 volt amperes VA, because I am just multiplying volt amperes. So I will get this as volt amperes. This is the apparent power. Apparent power. This is very important. Very important. Try to understand. So next question, that is nothing but active power or real power. Both are same. Active power or real power. What is the formula for active power? That means we are going to denote this is V into I cos pi, right? So this is the value of pi. Try to understand, right? This is the value of pi. See, we have seen these formulas before in RL circuit. We have written these kind of formulas. See, apparent power, real power, reactive power, or this will be called as active power, right? So you try to understand these formulas. And if I substitute these values, then it will be 230 into 2.2954 into cos of, what is this pi? This pi, I have already told you, you have to take it from the current value. That is nothing but will be the pi value. See, it is the RL circuit, then obviously your current will lag the voltage by some degree, and that some degree here is, which is nothing but 3.595 degree, right? So cos of, I will write here, it is nothing but minus 3.595. So if I simplify this, I will get P, which is equal to, that means real power, that is equal to 526.903 watts. This is the value of real power. This is the value of real power. And what is the reactive power formula? What is the reactive power formula? I will write here anyhow. So reactive power formula, that is nothing but it will be Q. Q will be is equal to VI sin pi, right? And if I substitute, this will be 230 into 2.2954 into sine of, here also it will be into, so here it is also into mark. So here it will be minus 3.595. So if I further simplify this, I will get Q, which is, so I am getting it as minus 33.103. See, this is VAR, bar, which means this is nothing but volt ampere reactive power. This is what? This is the normal power we are using, real powers, right? So this is the final value of reactive power, right? Next one, we need to find the power factor, right? That is the last thing, power factor. So power factor, I've already told you, there are so many ways to find power factor. Power factor, maybe I will write it as PF. We can easily find by cos pi, which is equal to cos of minus 3.595. So if I simplify this, I am getting power factor will be is equal to 0.998. That is the power factor value. See, this power factor, I will denote it as lagging power factor. Why I am denoting this as lagging power factor? Since my current is lagging the voltage by some degree, this power factor will be lagging power factor. Always in a RL circuit where where you can see inductors, the current will lag the voltage by some degree and your power factor will be lagging. And this power factor can be also find by a different formulas. By different formulas, I have already told you. See, getting the power factors, maybe power factor will be is equal to cos pi we know. And what is cos pi we have seen? That is nothing but it is R by Z. Right? We have seen these formulas in RL circuit. I have written this one. Where it is, maybe I will show you. R by Z. I have written somewhere. Somewhere I see, yes, here. See, it is nothing but R by Z. And what is R by Z? Or what is R by Z here? So, I will write here, which is equal to, what is the R value we have found? That is nothing but it is given value, right? It is given value 100 divided by, what is the Z value you got? That is nothing but this value 100.1972. 100.1972. 100.1972. If I simplify this, I am getting power factor PF will be is equal to 0.998. Right? So you try to understand certain things and what is this one actually telling us. See, I am getting the apparent power 527.942 volt amperes, and upon this value I am utilizing 0.998 percentage of this one. And if you want to get what is the, again a power factor, another formula can be also used. Power factor can be, and I think I have written that also in the RL circuit. See, whether I have written, see here, yes, I have written this one. What is cos pi? It is the apparent power with respect to the real power. That means ratio of apparent power to real power. So that also you can get here. Maybe I will write here. Power factor can be also written as P by S. And what is P here? That is nothing but it is 526.903 and divided by what is S here? That is nothing but it is 527. 527.942. And if I simplify this, it will comes out to be 0.998. So you try to understand upon how much of apparent power I am giving to the circuit, this circuit utilizing 99.8% of the given power. Try to understand, right? So that is how you need to find what is the power factor, and power factor will tell you how much of real power is utilized. That means the power which is really utilized by the loads will be determined by the power factor. That is why in AC circuit power factor plays a major role. The power factor can be found by different ways, but what the circuit is telling us, if there is a inductor and a, what to say, resistor and inductor connected circuit, there will be some reactive power which can never be used. That is nothing but it is 33.103 VAR. That these power will be oscillating between load and source and never utilized by load or source. So there are several things can be found with the help of the expressions we have found. So you try to get the points much more clear, and we will go to the RC circuit in the next class. In that you can also see real power and reactive powers. Right? That we will see in the next class. Anyhow, you go through this one, you will get an idea. Thank you.